This video will follow up on the previous video, which was talking about matter. In that video, we talked about mass and volume, and we also talked a little bit about the methods to calculate volume, such as the displacement method, and we looked into units. In this video, we're going to focus on density. So density is essentially, if we're just going to boil it down, is how tightly packed an object is. And what we're talking about with how tightly packed, we're talking about how many molecules are pushed into that amount of space. So the equation, therefore, is density, D, equals m divided by v. So if we're thinking of mass being the amount of matter and volume being the amount of space, what we're thinking about is how much stuff, how much matter is packed into that tiny bit of space. So if we come over here, I'm going to do some little math stuff for you. If D equals m over v, and we know that m is the amount of matter or stuff, and we divide it by the amount of space, right? And we're talking three-dimensional here, right? So this is kind of what we're saying is density. It's how much stuff you fit into a three-dimensional space. And a three-dimensional space can be very packed, full of stuff, or it could be loosely packed, full of stuff. It can be like glass of water A or glass of water B. In A, you've got a few red dots. In B, you've stuffed more red dots into that area. If we're looking at these two objects, A and B, it looks like there is more space. Like if we look right here, there's all this space right here, all these like random spaces here. These dots don't look as tightly packed in B as they do in A. A looks like they got really packed tightly into a cube. B looks like they probably got some space to move around. So B would be less dense. This would be less dense. This would be more dense. And the opposite for up here. This would be less dense. This would be more dense. Be packed with red dots. So units, there's going to be two units. Before, when we were talking about mass, we were talking about 5 grams. When we were talking about volume, we were talking about 100 milliliters, or 75 centimeters cubed. Now we're going to be talking about, since we're using mass and volume, we're going to be using 2 units all the time. So it would be like grams per centimeter cubed, or grams per milliliter, or kilograms per liter. Right? We can switch the size of the mass and the volume units there. So there will always be 2 sets of units. So if we come down here, I forgot the G in this practice problem here, but an object has a mass of 150 grams and a volume of 75 centimeters cubed. So really, that should be a 3 up here, a superscript. If you're working on the computer, you can always do the caret and 3. That will mean to the 3rd power, right? So density, if we're going to work this out, if we know that density is mass divided by volume, this is our mass, this is our volume. I will go through every problem and actually annotate, just like you do in English class. You have some reading comprehension skills, and make sure that you label the different pieces that you have to make sure that you keep them straight. I would also rewrite the equation every single time. So we take our mass, 150 G, divided by 75 cm to the 3rd. And see how I write the units in the problems? That's so that I remember in my answer what units I should have. 150 divided by 75 is going to be 2. G divided by cm3 will just be G per cm to the 3rd. Right? We can't actually divide grams by centimeters, cubic centimeters. So therefore, they end up in our answer. Right? That would be like in a math problem having 5x divided by y. We don't know what x and y are, so they're going to end up in our answer like that. So this would be our answer, 2 grams per centimeter cubed. So what that means is that for whatever object that we're talking about here, right, this could be styrofoam, this could be a piece of lead, it could be who knows what we're talking about, right? But whatever object we're looking at, for every cubic centimeter that it takes up, that cubic centimeter of that material is going to have a mass of 2 grams. So if we, you know how good my cubes are, right? So we're going to pretend that's a 3-dimensional cube, just so you don't have to watch me draw that horrible cube out. If that's our cube, that cube is going to have a mass of 2 grams. If I take another cube just like it, it will be another 2 grams. Another cube and another cube over here. So in total, because we've got 4 centimeters cubed, right? 1, 2, 3, and 4. Those are 4 of those cubic centimeters, 4 of those cubes. And we know that this object, each of those cubes, has a mass of 2 grams. So in total, this block of matter, of whatever this object is, since there's 4 of those cubic centimeters, we know that it's going to have a total mass of 2, 4, 6, 8. 8 grams total, because there's 4 cubic centimeters. Right? And this is all based on that. If we know how much mass is packed into each little tiny amount of volume, then we can start to figure out how much the total object, how much mass the total object will be. So if we only had half of one of these cubic centimeters, right, if we took one of the cubes and lopped it in half and got rid of this half, it was only half of a centimeter cubed, then it would be half of the mass. It would be 1 gram. So density is just telling you how much stuff we've smushed into a particular amount of volume.